Alright guys, so we're going to rip apart this pump. We're going to do like a little root cause failure analysis on this thing. So this is a pump. This impeller is going to spin in a direction. It's going to suck whatever they're pumping in, and it's going to shoot it out these vanes. After removing the bolt that holds this impeller on, I was able to use a little bit of heat and some pry bars to get a little bit of a gap so I could take this thing off. We obviously don't want water going into our electric motor, so these pumps utilize a mechanical seal made of different types of materials to seal out the motor from the pump. So with this mechanical seal, you're going to have a stationary piece and you're going to have a rotating piece. So this spring sits on the backside of our impeller here, which is going to help apply pressure to our rotating seal. Now this is a carbon and a ceramic mechanical seal. Once we've got the spring off, we also need to remove this key because we're not going to be able to get that seal off with that key sitting inside the keyway. You could use a punch or you can use a flathead. I usually try to grab these with some cutters and just kind of pry up and they'll pop right out of there. Once we got the keyway out of the shaft, we can go ahead and we'll remove the rotating assembly of this mechanical seal. Now if you pay attention right there, you can see that it kind of fell apart because this is our carbon piece here, which actually ended up cracking. So this rotating face is going to sit against our ceramic face. So here is our carbon face seal right here, sitting against our ceramic seal here, and these are going to be measured in helium light bands as far as flatness goes. It looks like somebody's attempted to take this apart. A bunch of these bolts are loose. They didn't tell us that they tried to take it apart, but, you know, just kind of digging into this root cause failure analysis, I'm kind of thinking somebody tried to take this apart. They were probably prying on this without removing the impeller first, and that is actually probably what damaged that seal. It seems like there was a lot of heat being generated regardless, so we're going to go ahead and remove this pump bracket. And right behind that bracket, you'll have these little, some people are going to call them flingers, some are going to call them V-seals, I don't care what you call it, but this thing's actually made out of rubber, and you can see that the heat has degraded that thing. We also have a broken ear on our end bell. The bearings sound like they're in tip-top shape, and once we actually pulled this fan cover off, to my surprise, there is no fan there, or inside of this, at all. I'm guessing they must have got one of those new, really fancy Bluetooth fans where it cools the motor without actually having to be on it. Now we can actually dig inside of this thing and see what's going on. So here's our broken end bell ear again. We're going to remove this opposite drive end bell, which seemed to come off with ease, which is never a good thing. Now inside of this end bell, where our bearing is going to fit in our little bearing housing here, these have to hold some pretty tight tolerances. We have to hold that rotor concentric inside of that stator, and you can see that this bearing fit, it's almost non-existent. It's just been completely destroyed. I've said a million times on here that motors don't normally just fail electrically. It's usually a mechanical failure leading to the electrical failure. This bearing is just locked up, almost solid. You can imagine that while this is running, that bearing is going to get extremely hot. So now we're going to take a little peek inside here at our winding. So our copper wires are running all through these slots, and all this little white stuff you see in here that kind of looks like drips or melted plastic, that's actually our insulation system melting from the amount of heat inside the electric motor. Every 10 degrees C we operate an electric motor over its normal rating is going to degrade our insulation life by half. Every 10 degrees C above that, we're going to half-life that again. It obviously failed pretty quick on our winding analyzers, so let's take a look at this. So I'm not saying this is what happened, but root cause failure analysis, we're just going to play around here. So that bearing's going bad. It's ruining this housing. It's creating a lot of heat on the end of this shaft here. So it's probably started creating noise because it melted the plastic fan off, they took the cover off, took the fan off, continued to allow this thing to just go through extreme heat, which wore out this bearing fit right here. And like I said, really tight tolerances. So once that bearing fit's worn out, this is electromagnets. It's going to suck that rotor to the side and it's going to drag it around in there until we cause enough heat and enough friction that we burn through that insulation. And ultimately, we grounded the motor, all because of that bearing failure. Just that little guy right there destroyed this entire thing. And if you don't think this is that common, there's the motor we just took apart, and here's the next one. You can see we can spin the fan right off the shaft. We go right inside. We got another locked up bearing causing heat. Melted the plastic fan, so the fan's not working, so we got more heat. Down in the bottom of that fit, you can see that little ridge. That's because now our bearing's locked up, spinning inside of that thing, just wearing out that fit, and ultimately destroying the winding again. Cheers, guys.